good morning. I'm Matthew, and I work at Style Education. At Style, we're trying to make science lessons fun, engaging, and interactive for kids in high school. Today, I'll be talking about code review, how you can take these lessons back and implement them in your development teams to get your development teams writing better documentation. This might be internal documentation, it could also be external. So, first off, we'll look at writing great pull requests, then reviewing technical pull requests, and then implementing code review in your culture. So, before code review, our developers were careless. It was terrible. You would see more build fixes, fix broken code. Working in IE, couldn't really reproduce it in Firefox. The test didn't work, so I commented them out. So we introduced the pull request. Pull requests are a way of branching off the main line of changes, the master branch, and making your own changes and then asking for those to be put back into the master branch. So this comes in the forms of commits. Pull requests can include docs and code commits. I think this is a real lesson for developers. They often just think pull requests are purely for code. So today I'm hoping to show you some tools that you can use to help them write better documentation as they write their pull requests. So let's get into it. Well, the first thing about writing great pull requests is that people don't fill in the description. I don't know what it is about developers. It's that they shy away from words or that they just don't remember. But it really helps to actually implement some context into your pull request. So when a reviewer comes in that didn't just spend the day trying to understand the bug that you were fixing, they actually have some context for what it was. They don't just see that you've moved some files around and changed a couple of lines of code. So this is an example that we're seeing from a bug from our support team. People are writing into our live support chat. You've seen those widgets that come up on marketing sites that ask you to chat to a human. So we use those for our users to be able to communicate with our support team. But people were coming in anonymously. So not only was the problem that we couldn't help people diagnose their issues, we didn't even know who they were. So I went and I found the cause. It turned out that we were initializing this library in two places, but only passing in who was actually writing into support in one. And then I made some changes to move that code into a shared module. Now you wouldn't know any of that context if I'd left this blank, and all you would see is that I'd moved some code around. So it's really important that you actually enforce that developers do explain the changes that they're making. This is the moment where their work actually becomes relevant to the business again. So the next thing to make pull requests great is write small ones. When I was a junior developer, I would start implementing a feature, and I'd start writing the back end of it, and then I'd start writing the front end of it, and then occasionally I might write some documentation, and the commits would be completely littered all over the place. It was really hard to tease apart what had actually changed. So now I try and make smaller pull requests. First implementing the back end in one pull request, then implementing the styling in another, and then putting it all together in another one. And what this does is it means that the reviewer doesn't have to tease apart Ruby code from JavaScript code. It means that they don't have to try and understand all the changes that I'm making in one go. It's easier to review code incrementally and for people to understand and to limit the context that people are reviewing. The next thing we implemented was we noticed that often developers would sit down, write their code, push it up, PR it, and then never look at it again. And what that meant was people didn't actually review their own work. And once we started asking people to review their own work, they started finding more bugs themselves. It saved our reviewers more time, and it meant that our reviewers could concentrate on the actual the stuff that the developer didn't understand or missed. So I want to talk to you about automation. I think automation is a great way to make sure that your pull requests are constantly getting reviewed. So we use Probot. Probot's a tool, it's like an app store for pull requests. So you'll see here, as soon as this pull request gets created, it gets assigned a reviewer by the bot. And this means that pull requests don't just sit there for a week waiting for someone to assign themselves and review them. They get automatically pushed through the queue. The next thing we introduced was a bot that asks our developers, have you updated the docs with this change? It's amazing how many people went, oh, actually I can write some documentation about the operations code that I just changed. And you know what? It's great, because in critical alert instances where our site's in trouble, it's great to have those documentation and to understand, really quickly be able to read what's actually changed in English and not have to read through the code. So I think this is probably the tool that's going to help your developers write docs that you can review really easily. We use a tool called Prettier. Hands up if you write any of your content in Markdown. So Prettier is going to change your life. What Prettier is it is a linter for Markdown, and it works for a number of other coding languages. It'll make sure that spacing is correct, that lists items aren't empty. It does auto-formatting for Markdown tables. It's really, really good. I can't tell you how much time I've spent in my life trying to get Markdown tables to render with getting the spacing right. This thing does it for you. And not only will it pick you up on when you've done it wrong, it'll rewrite the file for you. It also has a feature where if you specify a code block and you say which language it is, it'll reformat the code and make it more readable. So, you all said you use Markdown. Put your hand up if you think this would be a link in Markdown. This content here, what does this pass to? Is it a link?
Yeah. It's nested, so it's held.
Well, that would.
It's nasty, is what it is.
Yeah.
Well, that would depend on which Markdown parser you're using. Because the original implementation wasn't a standard, it was just a Perl program. But thankfully, someone's gone and written a standard for Markdown, Common Mark, and it's beautiful. It tells you exactly what's going to happen whatever's rendering the content that you're writing. And even better, Prettier enforces Common Mark. The next tool we implemented was called Alex. Yesterday there was an example of a developer referring to other developers as he. I think it was something like 53 times. Yeah. Alex will pick them up on that and it'll ask them to change it. The next tool we use is called Proslint. Proslint is kind of like your English teacher from school. It'll pick you up on redundancy, jargon, illogic, misspellings, just common phrases that people use in their docs that are problematic. And so if you use the word center and then use it again inconsistently, it'll pick you up on that. It looks for British and American spellings that are wrong. It'll also pick you up on stuff like apostrophes aren't needed here. And if you use 12 a.m., it'll suggest you use midnight. This is really helpful for developers because a lot of us come from science backgrounds or backgrounds where we haven't done much formal writing recently. And Pedant's another tool that looks really promising. It's coming soon. It will look for stuff like opening parentheses that aren't closed, punctuation, spelling mistakes, spacing issues, inconsistencies. It'll complain about empty list items. It'll ask you to write your numbers as words if they're less than 10. So I think with all those tools, one thing to note is they eliminate a whole class of issues. They eliminate a lot of nitpicking, and what that does is eliminate a lot of the time that you actually spend reviewing pull requests. So onto some things I look for when I'm reviewing technical pull requests. Well, in our documentation, technical accuracy is really important. It's really helpful to know that we can actually trust our docs, and it's important to keep them up to date. So if you don't understand something, ask another developer to come in, not the original author, but another developer to come in and help you understand it. I think that's just been something that we've seen time and time over again, is it's so important that you understand the code that you're reviewing. So the next thing is telling. This is from our internal documentation, and it tells you how to write a search method. For developers, we're pretty visual people. We like screens of code, we understand them. Big blocks of text are hard for us to parse. And yes, this could be broken down into a list or into just a more easily parsable guide. But including examples of how to write the code is also really helpful. And I picked this out of our code base, which is an implementation of this. And I realized that the description actually doesn't match exactly what the code's doing. And it was a really helpful way to tease apart what was wrong. So ask other developers to come in and help you write great examples if you're not super confident to write them yourself. The next thing is testing instructions. The amount of documentation we open up and try and run, that's actually quite critical to our infrastructure. That people didn't run or ran in their environment, but not on another environment. It worked on their machine, is really important. So it's really important to actually run any commands or any procedures that people are putting into their documentation. Another thing to look for is caching. If people are storing the results of their data so they don't need to recalculate it, if you're writing an API, for example, and the service you're requesting is rate limiting you, you might want to cache all the data. It's really important to know that this data is cached, and it's important to know for other developers when they come along to understand that that data isn't being refetched each time. Authentication. Whenever I try and use an API, the first thing I always have to do is figure out how to authenticate to that service. Everyone does it slightly differently, and OAuth isn't a perfect standard, nor is it super easy to implement. So it's really important that you document how your authentication works, and probably at the start of your docs. Failure modes are the other thing. It's really important, especially in operations circles, to know how software fails. And it's something that's really hard to tease out from the code itself. So this is from a piece of software called RabbitMQ. It's a message broker that we use, and it's part of our critical infrastructure. When it fails, it's really important that we're able to reconnect to it quickly. It can fail for a number of reasons, but the most important one is network problems. It's really important that they've documented all the failure modes that they have, because when you're in the middle, when you're trying to figure out why your website isn't up, it's really important to understand, oh, it failed because the network was down in this region. So understanding how things reconnect and giving specific examples of the exact behavior is really important. So this all sounds great, but how do we actually make it work? Well, the first thing is, sorry, I just want to go back for 1 second. Don't these people look happy? That pull request is getting merged.
It takes 5 of them.
So you don't want to do that. Never merge changes that you don't understand. I can't tell you how important this is. You will hurt your customers, you will hurt the developers that are involved, and the code will end up getting reverted. Because it's a good chance if you didn't understand it when you read it and reviewed the documentation, the developer probably didn't understand the code that they wrote or the docs that they wrote. The next thing we introduced was reviewer responsibility. So we wanted all our reviewers to understand that when they approve something, they're taking on some of the responsibility for that code running. If it gets deployed and then reverted, it's not just the author of the code that will need to be involved in fixing that. It's also the reviewer, because they've missed it too, and it's important that they both go back and understand what went wrong. So this is an example of trying to find all the users in your site that were created before 2018. This looks unassuming, and a junior developer could write it. The first line is selecting all the users. The second line is filtering them for people that were created in 2018. The only problem is it read the entire database into memory when it did this, which on a large site would bring down the site. So it's really important if stuff comes up that you don't understand, whether it's in documentation code snippets, that you really ask other developers to explain what's happening to you. This is something that we're trying out at the moment, and the verdict's yet to come back on it, but I think there's some real potential for it. It's enforcing that our entire team review internal documentation that we create. So our stack is quite diverse technically, and we're trying to encourage our developers to be full stack developers. And one of the issues with that is it's really hard to stay up to date with all the changes that are occurring, and getting everyone to review the docs keeps everybody up to date, so our iOS developer understands the changes that are going on in the back end. Ensuring that documentation gets updated every time you make a pull request and add files. This can just be as simple as checking that YAML files have been updated, and you can write a simple linter to do this for you. The next thing is code review shouldn't always be critical. It takes time to actually understand the work that your peers have done, and if it's great work, give them props for it. I think you'll find that if you think back to the last time that someone congratulated you or told you that you did a great job, you felt really good about that. And it's really important to find examples of great work and give props for them. It can be hard to have your work reviewed, but I think the most important lesson that I've found is when you get feedback, it's feedback on your work, it's not feedback about you. And it's really hard to separate those two things sometimes, but it's worth doing because the feedback will actually improve your work, and reviewers are genuinely, in 90% of the cases, trying to help you do better work, not criticize your work. But sometimes things get emotionally charged. People seem to get really, really attached to the work they do around the time they do it. Ask them about the work they did last week, and they're not as emotionally attached. Sometimes it can be hard when people are saying, I don't want to make these changes, or we can do that later, or let's just merge the code now and I'll come around to it. It's really important that you stick by your guns and make sure that just because someone's resisting doesn't mean that it's not an excuse for them not to meet the technical standards that you've set. And the next thing is, I think some of the best pull requests are the ones that get closed, because sometimes you just don't need the changes. Sometimes they won't help make things clearer for your users, and they'll actually end up hurting them. So go write and review great pull requests. Thanks.